Hello performance engineers and welcome back. Today we are tackling the true heavyweight of advanced workload modeling, the ultimate thread group. So if you have been following along with the JMeter framework series, you know that we started with the standard concurrency thread group. And this concurrency thread group is an excellent tool for hitting a specific target throughput and holding that traffic. It simulates a flat load, predictable load very well, but the real world is different. The real world traffic is rarely predictable or flat because the real world traffic composes of ups and downs, peaks and valleys, staggered arrivals, and different groups of users performing various actions simultaneously. So simulating that kind of complex load is what performance engineering is all about, and that is where we need to use more advanced thread groups instead of the standard thread groups. So that's where we are going to look in this video. We are going to look this advanced thread group called the ultimate thread group. So by the end of this video, you will have a complete understanding of this powerful component, and we are going to take an example and see and explain it step by step for you. And this will be a major step forward in your performance testing, where you can use this ultimate thread group to simulate complex workload scenarios. So let's look at this. So we have this JMeter open, and to add the ultimate thread group, you have to create a new test plan and then right click on the test plan and add threads and then select the ultimate thread group. So here you see this. So that's how you add it. So this is the thread group you see here, and we have the name. You can give any name and the comments and all the actions to be taken after a sampler error. I have explained this continue, start, and all these options in another video. I will put a link in the description. But let's move towards the actual thread schedule, as you can see here. So you can see add row, copy row, and delete row. So let's look at the columns first. The first column is the start threads count. So this first column defines the maximum number of users. So let me add right now we have no rows. Let me add a row and then explain you. So we have here with a default of 100 threads or 100 virtual users. So this specifies the number of users that will be created within this specific group. So for example, we have here 100 users. You can have 50 users or any number of users. So this will be our consistent traffic. So next column is the initial delay, which is in seconds, and this column sets a hard delay. That means you specify here how many seconds the JMeter has to wait before it can ramp up the load. So here we have 0. That means JMeter is going to ramp up the load immediately. So you can see here it's going to immediately ramp up the load and reach the 50 target users. Suppose if you want to delay the test, maybe your environment is warming up, your Lambda is warming up or something like that, and you want to stop the test, pause the test for 60 seconds. So you can see that nothing happens for 60 seconds, and only after 60 seconds JMeter is going to start ramping up the load. So that is your initial delay. So initial delay is very powerful when you want to have a staggered modeling. So we will explain as we go along in this video. And the next column we are seeing here is the startup time, and this startup time is also in seconds, and this is your ramp up period. So you can see here after 60 seconds that JMeter is ramping up the load, and you want to define, this is used to define how fast you want the JMeter to ramp up the load. Do you want the JMeter, you're telling the JMeter to ramp up the load from 0 to 50 users or 0 to 500 users or whatever peak load, how much time the JMeter should take to ramp up this load. So here we see 30 seconds. That means in 30 seconds JMeter is going to reach that target load. So it's going to increase this. Suppose you want no startup time, you want to directly simulate a spike, for example. So JMeter is going to immediately start all the 50 users simultaneously. So you can you can adjust your times according to your scenario. Suppose let's say you want a slow ramp up, really slow ramp up, then you can say I want to take 10 minutes, so that JMeter will take 10 minutes to ramp up the load. So that is what this one is. So that is at startup time. So you can see here the load is added smoothly, and this is for the uniformity. So avoid any startup time of 0 unless you want to simulate a sudden spike, for example, or a sudden increase in load. So in that case, you might want to use 0. And the next column is, let me change it to a realistic value, for example 60 seconds. So next, move on to the hold load for seconds. So this defines the steady state. So you can see here, once the load is reached to 50 users, how long you want the JMeter or your load scenario to run with this constant 50 user load. So you can see here 60 seconds, that means the test is going to run for 1 minute, which is 60 seconds. It is going to maintain this 50 user load. Suppose if you want to run the load test for a long duration, let's say for 10 hours to check any memory leaks, or for example you are doing a soak test, so you're going to hold this load for increased number of time. But for this example, let's keep it 60 seconds. And the next is the shutdown time, which is also in seconds. So this is a ramp down period. So it sets the exact number of time in seconds for all the 50 threads or whatever threads you have in this group to gracefully stop. So let's say you want to stop the test really slowly in 1 minute or in 5 minutes, or let's say in 10 minutes you want to bring down the load. So JMeter will take 10 minutes to bring down the load gradually before it can completely shut down all the users. So that is what this one is. So row alone, we have created one row here. So let me make this as 60. So we can see here, and let me remove this initial delay so it is clear. So you can see here we have created one row. So this one row alone creates a simple trapezoid like thing. So you can see here, so 0 to 50 users, and it's maintaining a flat load, and then it comes down gradually. So this one row simulates just a regular. So this alone is already more powerful than a standard thread group. But the ultimate thread group, what is the speciality, lies in the stacking. So you can stack another row here. So that's where this ultimate thread group becomes indispensable. So now that we understand all the core columns, so let's look at how to add another row. So let me add another row, the second row, and you can add another row. So they all have the same, they have their own individual delays and startup and hold seconds and shutdown time. So each row is completely a different stack. So let's delete this row, and let me just add the second row. So here we have 100 users. You want to start that 100 users, and you can put a delay of, let's say I want to start the users after 2 minutes. So let's see. So you can immediately see your graph. So you can see here 0 to 50 users, the first row, and this is a startup time, so 60 second startup time. So in the row 1, 50 users start, take 60 seconds to ramp up, and then the hold state is 60 seconds. So that's row 1 is going on. So row 2 is another stack. So here 100 users after initial delay, let's say after initial delay of 2 minutes, because you want the first row to reach the steady state. So after the steady state is going on, at the 2 minute time, the load is again increasing, adding another 50 users. So 100 plus 50, so you get 50 users added in the first stack 1, that is row 1, and it's going on. And while that is going on, you are adding after 2 minutes another 100 users. So 100 plus 50, so now you have a total of 150 users, and it's coming down. So you need to adjust the load. Let's say you want to hold the load for a longer time, and you can see here how long that load, and you can see there is a dip because this load is coming down. It's holding only for 2 minutes. So let's make this as 120 seconds, for example. So you can see here how both loads, the total of 150 comes here. So you need to adjust the timing. So this looks kind of different, but you can add another. So this is how you adjust your time. So you can look at the picture and then adjust your timings. So your startup time is 30 seconds. You can increase it to 60. So you can control each. So each step is each row is completely independent. So you can add another row and do the same thing. So this might look, but if you think about a real world scenario, the graph looks even more uniform. And I can say, let me show you that. So let's say the startup time is 120 seconds, and now it looks more realistic. Now it looks, you can see here the row 1 is the stack 1 going to 50 users, and then the stack 2 adds another 100 users, and both of them, and the total users is 100 here, and it is maintaining a steady state load. So you can configure this like this, and then the shutdown time is 10 seconds, and you can adjust it. So this is a realistic load. So you can see how you can create your own complex scenario. And let me add another row and show you. So I have this example here, so I can show you this ready-made example that I have built. So I have a good example I want to show you. So let me see. So here it is. So here is a nice example, and here is a nice example. Here you can see here there are 2-3 stacks here. So the first stack is 100 users, and they have their own initial delay startup, and the same thing. So you can see here how this is a more complex scenario. So this is an example to show you that how you can build even more complex scenario. So this stacked scenario is what we saw. This models a complex workload. So this is a good example. For example, the users, there are 200 users going on at some point, and then the load comes down and then stays at a lower load level, and then again a load is added, and you can even reduce the startup time to increase a sudden spike in load. So you can say that I want add another row with 100 users coming in with no initial delay, a sudden spike in load happening while in the middle of the test. So let's say, so this spike comes after some time. Let's say after 5 minutes or so, you want to simulate a sudden spike of 100 users coming into the load. So this might be your production scenario. Everything is going fine, you have flat load, and then suddenly you want to simulate a spike in the middle of the test. So this is another complex scenario, and a concurrency thread group cannot do this. So that's the powerful power of this ultimate thread group, where you can simulate a spike and then maintain a flat load, and then you reduce the load abruptly, you increase the load suddenly, so you can simulate those sudden spikes and sudden shutdown, that is the decrease in traffic or sudden increase in traffic, those kind of things. So standard groups cannot handle these stacked schedules. So the concurrency thread group cannot handle these complex variable and non-linear schedules. The stepping thread group is another thread group, but that is too simple. For any scenario that requires this kind of a granular control, and you want to simulate multiple peaks, so you can add even more rows there, so there is no limit. So you can simulate even more complex with each stack having their own configuration, the whole time, shutdown time. So you now have a total command of every setting in the ultimate thread group. So mastering this component unlocks advanced workload modeling. So you can model any complex scenarios, and that elevates your testing capabilities. So you can now build sophisticated, realistic, multi-scenario simulations that were previously out of reach. So let's continue. In the next video we will look at a more powerful thread group in our framework, and subscribe to the channel so you don't miss the future videos. And if you have successfully created a multi-peaked scenario or any other complex scenario using this tutorial, let me know about it in the comments below. Thank you for watching this video, and I will see you in the next one.